Okay, so identifying more types of chemical reactions, more examples here. That's what this flashback is all about because a lot of people struggle with this. We really want to ingrain it into your brain so that you can understand it better. Okay, so let's look at some examples that I have here. Now, if we look at the first example, the CH4 plus 2O2 reacts to give you your product, CO2 plus 2H2O. This equation is already balanced for you, and you just need to simply determine out of the 5 types there are what type of reaction it is. So let's review our 5 types. We have synthesis, we have decomposition, we have single replacement reactions, double replacement reactions, and finally our 5th one, combustion reactions. Okay, so I'm going to go over the definitions of each of these, and then I want you to be able to be aware of which definition matches this example right here. So synthesis is when 2 single elements come together to make one new product. Do we have 2 single elements here? No, we do not. So this is definitely not synthesis. Decomposition is the opposite of synthesis. It's where one compound reacts with heat or light and then breaks down into its separate elements. Do we have just one compound here, breaking down into single elements? No, we do not. So it's not decomposition. Now, single replacement is when one single element reacts with a compound, switches places with the guy who has a like charge, and then forms a new single compound. And then forms a new single element and a compound. Is there a single element over here? No, there is not. There is a single element right here, but a single element must be present on both the reactants and product side, and there's no single element over here. So it's not single replacement. Double replacement is where 2 compounds, when they react, the cations will switch places with each other, or the anions, as long as it's a like charge, it doesn't matter, to give you 2 new compounds. Now, do we have 2 compounds over here reacting together? No, we have a single element with a compound, giving us 2 new compounds. So that doesn't quite fit the double replacement reaction definition. So let's rule that one out. So finally, let's hope it's combustion. We have combustion, our 5th and final reaction. Now remember, combustion is when a hydrocarbon, so a hydrocarbon is just with a carbon bonding with a hydrogen, reacts with oxygen gas to give us our products, CO2 and H2O. These products are the same every single time, no matter what. So if we look here, we have a hydrocarbon reacting with oxygen gas to form CO2 and H2O. So this equation looks just like a combustion reaction, so therefore it must be combustion. So this first example is definitely a combustion reaction. Now let's look at our second example. Got to rewrite the 5 types. Okay, so remember synthesis, 2 single elements coming together to form one new compound. Okay, I have one single element, but then a compound, not a single element. And it's supposed to form one new compound, not 2, so that's out. Decomposition is when one compound reacts to something like heat or light and breaks down into its separate elements. So here, I don't have one compound. I have a single element with a compound. And it's not breaking down to its separate parts. Okay, so it's not decomposition. Single replacement is when you have one single element reacting with a compound And when it does that, it's going to give you a new single element with a new compound. Well, I have one single element right here reacting with a compound. And he seems to look like he's switching places with Na. So Mg is switching places with Na to give me a new single element and a new compound. So this one definitely looks a lot like a single replacement reaction. So now that you have been refreshed on how to identify the types of chemical reactions given an example, you can now use this to help you answer the questions